Hey maths friends, welcome to this funky video with Mystery Maths Tutor. Mystery Maths Tutor. There you go. Thank YouTube. We need all these cool introductions. Hopefully whilst the jingle's been going on, you can stick this title in your book. Pause the video, get the title in your book, and we'll get going. We're going to differentiate sinx and cosx from first principles. So I'm going to quickly recap differentiation from first principles with you. You've now got your green formula sheets. You can get these out of your books or wherever you've got them, and you'll have this on it. So I would make sure you can find where that is. It actually gives you the formula for first principles, so you don't actually need to worry about remembering it. So what we're going to do is we're going to differentiate this from first principles. So I'll go through this one. There'll be one for you to go at in a minute anyway. So I'm going to write f dash of x equals 3 lots of x plus h to the 4. I've swapped x for x plus h minus the function I'm differentiating, which is x plus 4, not x plus 4, 3x to the 4, and all divided by h. Now I've missed out my limit bit. Now there's no equal signs with your limits either, so you don't need any equals here, just the one here. So I'm now going to have to expand that using a binomial expansion. Now I'm going to do this at the side. You can do 4 choose 0, which is 1. 4 choose 1, which is 4. 4 choose 2, which is 6. 4 choose 3, which is 4. And you can type them in your calculator if you want. Or, if you know what they are, there's 1, 4, 6, 4, 1 from Pascal's triangle. I'll then get x to the 4, x to 3, x to 2 and x, and then up is h4. Notice how they all add up to 4, all the powers. I'm now going to put them into my formula. Now this time I'll write the lim correctly. So limit, as h goes towards 0, of 3 lots of what I've just expanded with my binomial expansion. So x to 4 plus 4 x cubed h plus 6 x squared h squared plus 4 x h cubed plus h to the 4 minus 3x to the 4. So just remember the binomial expansion is going to be useful in here. Next line, I'm going to times everything by, well, not everything, I'm going to expand the top. I'm going to just quickly do that. So I've just expanded the top, the speed of light, and then get minus 3x to the 4 all over h. You'll notice here that that and that will cancel. That'll always happen. You'll always get something cancelling. That'll be important in the video here. So I'll just write that out with the red bit's gone. So you now get all this. I'm now going to divide everything through by h. So you get 12x cubed plus 18x squared h plus 12x squared h squared plus h to the cubed. As h goes towards 0, well, that's going to be 0, that's going to be 0, and that's going to be 0. And there's no limit anymore because we've just done that limit bit. You get 12x cubed. Now, the way to check it is differentiate the question. Oh, yeah, I'm right. So, have a go at that if you're really unsure. What I'll do now is I'll put on a question for you to have a go, and have a go at this next one. It's definitely the same idea as before. Don't forget to use x plus h for x, so it'll be 2 lots of x plus h to the 5. Use the binomial expansion on that. So pause this video, have a go at that, and then we'll chat through the answer. Do it on a piece of paper to hand in with your tutor, this one. So I think there's 2 or 3 of you to have a go at, or 2. So pause this, have a go at it, and I'll go through the answer. So, here's the answer. That's my function, and then subbed in x plus h there, and I've got my formula next to it in there. Then got 2 lots of that, that's h to the 5 at the end, and then that's had to just drop down there. I've expanded all that out in one line. These two cancel, which gives me that. Divide through by h, which gives me that, and then as h goes towards 0, only that remains. And you can check it by differentiating it. Probably about 3 or 4, well, it's got binomial approximation, so it's probably about, not approximation, expansion. So you get about 4 or 5 marks for that, so it's definitely worth knowing it. Okay, now we're pulling out the big boys and girls. If you want to write this in your book, you can. at the top, and then jot down example 1. Okay, we're going to go through this now together. I'm going to let f of x, we can write that if we want, let f of x equals sin x. So my formula is f dash of x equals the limit as h goes towards 0 of sine of x plus h, so just swapping x for x plus h over that, well, minus sine x all over h. So, you'll now notice something special. The angles are different, yeah? So we need to use the addition formulae on that. So this equals, again, the limit as h goes towards 0 of sin x cos h. Now, cos does mean something, but we'll just do sin h. You can put brackets around these if you want. Plus sin h cos x, or whichever order you want to write them, minus sin x all over h. So, addition formulae on that. You're going to use that in the whole questions. So that's why we've waited a bit, because we need to be good at these addition formulae. You now know something. H goes towards 0. H gets really small. So, and I'm going to just put this in a line, as h goes towards 0, we know that cos of h goes towards 1 minus h squared over 2. That's a small angle approximation, because if h is small, that's a small angle. Similarly, that is roughly the same as h, because if h goes towards 0. Now, I'm going to then put them in now, so I get my limit as h goes towards 0 of sin x times by this, the small angle approximation, plus h cos x, using the other small angle approximation for sine of h, sin x, all over, do that a bit better, all over h. I'm now going to expand that out. So this equals the limit as h goes towards 0 of sin x minus h squared over 2 of sin x. Oh my gosh, just noticed something. I did say this before. They will cancel out. Now I'm going to quickly just divide through by h. I've not done this h goes towards 0 yet. So I get minus h over 2 sin x plus cos x, which, I'll put this on the line under, I can fit it on, which is cos x as h goes towards 0. Okay, so that's your answer. Now, I've got a nice written up one now that I'll show you, and you can copy it down in your book. So in fantastic Blue Peter style, you let that happen, sub it in the formula. Sub in x as x plus h. Use the addition formulae, so you can put that note in your book, and you get that. When h is small, they're equal, because using the small angle approximations, so you can sub them in. Now all I've done is I've expanded the bracket, and I get this. And you notice, like I said before, the sin x will cancel with the sin x at the end, like in the ones we did before. You then get that. I'm going to divide this by h and this by h. Divide everything by h. You get this. Now, as h goes towards 0, this is obviously going to go towards 0, because it'll be 0 times sin x. Hence, f dash of x is cos of x. Beautiful. How I've managed to prove that to you. Okay? Get that in your books. Flick back if you want. Pause it. Make sure you know what's going on there. I've seen this in a practice paper that's going on. So make sure you can do this, and then we'll do example 2. Hi again, chums. Alright, we'll do an example 2. Differentiate y equals cos 2x from first principles. Now, this is a little bit sneaky. There's something you've got to watch out for. It's like I'm talking from experience, because I missed it off first time I tried to do this. So, I'm going to go f dash of x equals the limit of h going towards 0 of cos of 2x plus h. Now, usually we put brackets around that, but I'll leave it for now because I kept missing them and messing up. That's what you set up, which is the same as cos of 2x plus 2h. I'm now in the same place as I was before. I'm now going to have to remember, though, that it's 2x plus 2h because it's two lots of this. Because now I can sneak him in and put him in a different blue, in just a dark blue. That's, you can have brackets around there, can't you? Because it's cos of all that. Don't need them, you can have them. I think I've put them in later in my full written one. So I'd watch this and I'll do what I did before and show you my full nice answer. And now we're going to use the addition formulas that are in your formula book on this. So you get cos 2x, cos 2h, minus... Now I know these off by heart, you can check them in your formula book, but it's quite nice because that's obviously double angle formula, is cos squared minus sine squared. Okay, now we need to use the addition small angle approximations. So, as h goes towards 0, cos of 2h is going to be roughly equal to 1 minus 2h squared all over 2, all squared, which is 1 minus 4h squared over 2, which is 1 minus 2h squared. Similarly, or easier, sine of 2h is 2h. So that will mean I can replace this here with this, and this here with this. So that's using these addition formulas here. So, to carry on with my line of what's going on here, I'm clearly going to expand this bracket here and what's going on, which gives you cos 2x minus 2h squared cos 2x minus 2h sine 2x minus cos 2x all over h, and again, boom and boom. Should always happen, as I said. Now I'm going to divide through by h, which gives me minus 2 h cos 2x minus 2 sine 2x, which I'd write underneath, but I've got no room left, have I? That equals minus 2 sine 2x, because this will go towards 0. Don't copy this one up. I'm going to give you the nice answers now. We'll talk through it again, and then you can have a go at it. You probably stop it and do it yourself, because the next one is balls in your court. Set f of x as 2x. Now you're subbing in all of x for x plus h, so you get this, which expands to give you the angle 2x plus 2h. You need that because it will come important later on. Use the addition formula. When h is small, you get this for the small angle approximation of cos of 2h, and the sine of 2h just goes to 2h. They're in your formula book. And then sub them in. So pause that here and maybe get that line down, because they're the harder bit, is using the addition formula and the small angle approximations. So now I've expanded the bracket and wrote that down. Then these two here cancel to give you that. Divide that by h and that by h, which gives you that and that. And then as h goes towards 0, that goes towards 0 here, which just gives you the answer at the end. So pause there, make sure you've got the two examples in your book, and you're going to have another go at one after the differentiation for first principle review we did at the beginning. Okay, here's your go. This is fairly straightforward. It's very similar to the one I've just done and the other one combined. So, use differentiation for first principles to show that sine kx differentiates to k cos kx. It'll always tell you to use first principles if you're using this method. If it doesn't say, you can literally just differentiate that to that. So it says use from first principles or use differentiation from first principles, something along those lines. So that's how you spot these questions. So pause this video here, have a go at it yourself. If you need to watch the slides back, the video back, you can use your book. Try and do it without, and then we'll go through where the marks are. So pause this video here, and off you go. Okay, we'll now go through the answer on this one here. So, this is part of the answer. Let f of x equal sine kx. You're going to sub x as x plus h in here. Remember what I said before with the 2? This time you get kx plus kh. Got to just be careful with this. I think you just have to concentrate on what's going on. Here, you then use the addition formula on this to get sine kx cos kh, cos kx sine kh, because that's A and that's B in each case, and you get that. We're now going to use a small angle approximations on this and this. So, that's the answer from before. And here's your small angle approximations. I'll just put them afterwards. It could be up here, it doesn't matter. So cos kh goes to this. Sine kh goes to this. So just change the order around here. Expand that out, and you get that, and that, and that, and that, as such. Just drop the brackets afterwards. You can have them, you don't have to have them. These cancel here, and I'm going to divide through by h. Probably do it on 2 lines, and you get this here. That goes towards 0, so you get your answer as required. And I've just kept putting the brackets in and not because inconsistency. But I'd put the brackets in is absolutely fine. You don't necessarily need them because you know what you're doing the times in first and then the cos in. I hope you found that useful. If not, watch it again. Make sure you get your head around it. Probably won't explain it in any other way than I have. Just bear in mind to expect to use the addition formulae and the small angle approximation. So it's a good recap of that. If you want to have a go at some on your own, why don't you just pick some? Why don't you differentiate that from first principles? Or how about that? You're working the same way. And you know what the answers are when you differentiate them, so you can check them. Cool. I hope you found that fun. I've not got a jingle to end it with, unlike the beginning. So until next time, maths chums. Bye-bye.